So the other way that we can use cross multiplying with proportions is to solve for an unknown in a proportion. Okay, so they might ask you to solve for x in a proportion such as, all right, 3 over x is 8 over negative 15. What is x? All right, 3 is to x as 8 is to negative 15. What is x? So again, whenever you have a proportion, right, basically which amounts to two fractions equal to each other, just use your cross multiplying. So you're doing 3 times negative 15 equals x times 8, which I'll just write as 8x. And then this is going to be negative 45 equals 8x. And then you divide by 8. And negative 45 over 8 is actually going to be negative 5.625. Because it's negative 5 and 5/8, and 5/8 is going to be 0.625, so it's negative 5.625. And I am going to write this as a decimal actually here. I mean, if it was a repeating decimal, then I would probably want to turn it into a fraction or a mixed number. But since it's a nice terminating decimal, I'll just leave it as a decimal here. So that's one thing that you could do. Well, that's the other thing that you could do, right? Solve for the unknown in a proportion. And you just do it by cross multiplying. So one final thing to be aware of with these proportions is the difference between when you have a proportion and when you have a multiplication problem, right? Because that's basically the difference between cross multiplying and potentially cross canceling, right? And these are things that people a lot of times get confused. So what I mean by this is, let's say you have something like, all right, 2 is to 3 as x is to 4, but then you also had 2/3 times x over 4. These are different types of problems, right? The first one has an equal sign between two fractions. This is actually a proportion. So this is a proportion where cross multiplying applies, right? This is going to be a multiplication problem where you can actually do your cross canceling, right? So with the proportion problem, all right, well, this is what we've been doing here with cross multiplying. So we just do a times d equals b times c. So we're going to have 2 times 4 equals 3 times x. So we're going to have 8 equals 3x. And we're just going to divide both sides here by 3. And here we're going to actually get the value for the variable, which is 8/3, which is actually going to be 2 2/3, which I'll write as 2 2/3 in this case because it's a repeating decimal. I don't want to write it as 2.6 repeating, so I'll write it as x equals 2 2/3. But now over here, remember when we did multiplication, we had said, well, you could do the brute force method, right, which is just multiply across the top or multiply across the bottom, or you can do this thing that we call cross canceling, right, where we can say, all right, well, 4 is really 2 times 2, so this 2 would cancel with one of the 2's here, and then you'd end up with 2 down there and 1 up there, and then you would do your multiply across the top and multiply across the bottom. So this would be 1 times x, which is x, over 3 times 2, which is 6, right? So this just becomes x over 6. And again, this was also the difference between an expression and an equation, right? The proportion was an equation which we could actually solve for the variable, right? So we end up with a solution, x equals 2 2/3, whereas this was an expression which you're not solving for the variable, you're basically just simplifying it. So 2/3 times x over 4 simplifies to x over 6. We're not getting a solution for the variable because this is just an expression, whereas the proportion is actually an equation, right? So here we get a solution, there we can just simplify, right? Solving, simplifying.